Okay, so hello all, welcome to my channel. So here I'm just going to teach the second chapter of social computing, that is network measures. I'm just going to teach you the main and core part of the chapter because this is the exam season, and we're having very less time to study also, because I'm also having my exams onward. That's why I'm just going to teach you the major and main part, which is most important for the exam. And I have taken the second chapter because the first chapter is not that much lengthy, and it is simple to understand also. So I'm just taking the second chapter. Centrality. Okay, so centrality defines the importance of node within the network. That means if I'm having node v1, v2, v3. Okay, so how much this node v2 is important in the network is the centrality of that particular node. Okay, so that is the centrality. So we are having so many types of centrality here. That means degree centrality, eigenvector centrality, card centrality, page rank, closeness, betweenness, group centrality. We have to study all of this centrality. Okay, so first of all we are going to start with the degree centrality. Okay, so how many connection or how many number of connection of a particular node. That means the v1 is having a connection to v2, v2 is having two connections in the network. For better understanding, we are having a diagram. That means the number of connection to v1 in this whole network is more, so the degree of centrality of v1 is also more. Okay, but for v7 the connection is only 1, so degree of centrality of v7 is very low as compared to v1. Okay, so we are having two types of degree of centrality. The first one we are checking, that is for undirected graph, and the formula is degree of centrality CD for particular vertex vi is equals to number of adjacent edges di, and for directed graph it is equals to number of adjacent edges which is ingoing in, and for outgoing it is out, and the overall centrality is summation of ingoing and outgoing number of adjacent edges. So yeah, that's the degree of centrality, and these are the whole formula. But there is a one issue in this degree of centrality. That means if I'm having 10 followers in LinkedIn and 100 followers in Instagram, at that time this centrality cannot allow to compare across this network. The centrality I can't compare the centrality across the LinkedIn and Instagram. So that's the drawback of the centrality. That means the degree of centrality measures does not allow us to compare centrality scores across the network. I cannot compare the Instagram follower with LinkedIn follower with Instagram. That is the drawback of this centrality. So to overcome that, we are having the normalizing degree of centrality, and it is also having three types. Okay, so the first one is based on number of nodes, and what is says that degree of centrality of number of nodes for normalization is equals to di by n minus 1. That means if I am having 100 followers in Instagram and 10 followers in LinkedIn, then the degree of centrality of number of nodes is equals to 100 divided by 10. Okay, so this is for the first one. Similarly, for maximum value of degree of edges, we are having this one, the second one. That means we are going to divide the number of degree of centrality divided by the maximum number of maximum degree of edges. That means divided by this, because this is having the more number of degree. Okay, then we are having the third one, and we are going to divide the third one by summation of all the degrees. That means summation of all these degrees we are going to divide in this, the third one, normalization. So that is the degree of centrality in this chapter.